So guys, this is our 16x2 LCD. You can see we can show you learning microcontroller written on it, and behind it is the PIC16F877A. Let me give you a glimpse of the programming. So in the programming, we just initialize the LCD using our selected pins. Then we use only this command, LCD out, start writing from the first row, first column, write learning in the first row, and in the second row, start writing from the second row, first column, microcontroller. And this programming gives us this result over here. Hello guys, welcome to Learning Microcontrollers. In this video, I will show you how you can interface a LM016 16x2 LCD with a PIC16F877A microcontroller. So let's get started. So guys, this over here is our 16x2 LCD. You can see there is a port here from where you will do the connections. It has 16 pins. If you hold it like this, from left to right, it's 1 to 16. Then we have two rows here. That is why it's called 16x2, because we have two rows, 1 and 2, and 16 columns in each row. So it can display 16 characters. One column means one character on one row, and at a time you can display two characters on both rows. So it can have 16 characters on one row and 16 on other. Total you can display 32 characters at a time. So let's get started. So guys, this over here is our PIC16F877A microcontroller having 40 pins. It's a DIP version. It's also available in the SMD version as well. So this over here is our 16x2 LCD, and this over here is a 10K potentiometer. It's a variable resistor or a potentiometer. Guys, we will need this to adjust the contrast of this LCD. This LCD's contrast needs to be adjusted, so you have to use this resistor. It can be of other type as well, but it should be a 10K variable resistor. Now let's do the connection. As we know, this potentiometer or a variable resistor has 3 pins, 1, 2 and 3, also mentioned on the body as well. Here 1 and 3 are the fixed pin, the 2 is the variable. You can see on the body as well. So whatever the potentiometer you have to do this. Now guys, the next thing is the 16 pins of our LCD from 1 to 16 from left to right if I hold it like this. Now first of all, you connect the pin number 1 and 5 of your LCD like this. Then you connect it to the pin number 1 of your potentiometer. From there you send it to the common ground of your PIC16F877A microcontroller. In this way, your potentiometer and your LCD gets a common ground. Now guys, next thing is the pin number 2 of your LCD. This is a power pin connected to the pin number 3 of your potentiometer. Then you send it to the VCC pin of your PIC16F877A microcontroller. Now here, remember the PIC is being powered up using a 5-volt source. So 5 volt goes to the potentiometer, 5 volt also goes to the LCD. In this way, our LCD gets powered up and the PIC gets powered up and the potentiometer gets the power. Now guys, pin number 3 of your LCD is the adjustable contrast pin. You have to connect it to the adjustable pin of your potentiometer like this. In my case, it was the center pin. Now pin number 4 is the RS pin. For this, you may use any available digital input output pin of your microcontroller. I'm gonna use the pin number D1 for the RS, and then the enable pin, that is pin number 6 of the LCD. I use the D0. Now 7, 8, 9, 10, they are D0, data pin 0, 1, 2, 3 and 4. Just leave them. I directly go to the data pin 7, that is pin number 14 of the LCD. I connect it to the pin number 30 of my PIC16F877A, that is data pin 7. Now guys, port D pin 7. Now guys, pin number 13 of the LCD, that is data pin 6. I connect it to the pin number D6, that is port D pin 6, and data pin 2, that is pin number 12 of the LCD. I connect it to the D5, 11 to the D4 like this. Now guys, these two pins 15 and 16, they are for the LCD backlight. This LCD do have a backlight. If you do not connect these two pins, your LCD backlight will not turn on. Still your LCD will work, but it will be very dark to see. Now the pin number 15 is the 5 volt pin, LED backlight positive, and 16 is a ground. Just connected to the positive 5 volt supply and the ground from which you powered up the LCD. The same supply will also be able to power up the backlight as well like this. In this way, our connections are completed. Now pin number 7, 8, 9, 10, as I told you earlier, they are data pin 0, 1, 2, 3. This LCD works in 2 modes. One is the 4-bit and one is the 8-bit mode. For our application like sending strings and displaying data, 4-bit mode is more than enough. So for the 4-bit mode, you do not need these 4 pins, D0, D1, D2 and D3. Just leave them floating. No need to connect. Now our connections are completed. Now we will program this PIC in such a way that it will show here hello world or learning microcontroller. We will send a string on this screen from the programming of the PIC. So let me introduce you to the hardware before we move on to the programming. So guys, this over here is our hardware. As you can see an LCD and then a PIC16F877A development board. I built this board and I also have a lecture on how to design it. So you can just design and get it manufactured or manufacture it yourself, not a big deal. So you can see that there is the LCD, there is the adjustable contrast register. You can see that blue register over there. So resistor over there. So that's all you need. So this is our simple hardware. Now let's get to the programming. So over here is our MikroC for PIC. You may use any version that is available. I also have a lecture on this, how to download and install this tool for free from the official website. Please do check that. Click on File, New Project. This window pops up, New Project Wizard. Click on Next, write the name of the project. I write here LM016 LCD tutorial by learning microcontrollers. So you may write any name. This is the path where your files will be created and saved. Select the microcontroller you are going to use. I'm going to use a PIC16F877A. The crystal I have with the pin number 13 and 14 is 16 megahertz. I select that, click on Next and Finish. So guys, this window pops up. Before you do anything else, first of all, go to File and save your work. Click on Save. Okay, it's saved. Now guys, first of all, we need to initialize the LCD. Go to the right. Here you have the MikroE libraries. Go to the system libraries. Here you have this command called LCD, this library. Checkmark this, expand this. Here you have this command LCDI90. Double click on this. This window pops up. And in the example here you have these commands. This, copy them till here, only here, till here. Now paste it above the void main. Like this. Now these commands will decide which pins you are going to use for the function LCD to initialize. Like I told you, you may use any available digital input output pin. I will write the pins I am going to use. I am using pin number D1 for the RS, D0 for the EN. Then I have pin number D7 for the D7 of the LCD. Then D6 of the microcontroller for the D6, D5 for the D5, and D4 for the D4. Now see the beauty here. That's why I selected these pins. So they align directly with the variable named. Port D pin number 7 of my PIC is connected to the LCD pin D7. Port D pin 6 to the D6, D5 and D4. If we were using it in the 8-bit mode, then we were also to mention here D3, D2, D1, D0. Since we are using this in the 4-bit mode, so we only need these 4 pins. For the 8-bit, you also need those 4 as well. So here also do the same. That was for the pin initialization. Now this is for the pin direction, that either the pin is input or output. Just do the same. This is RS pin. RS we are using D1. Enable I am using D0. Now for the D7 I am using D7, D6, D5 and D4 like this. Now guys, we initialize LCD. Again, go to the right in the LCD and I90 library, double click. There you have this command called LCDI90. Copy this command and you will paste it in the void main loop like this. Now give some initialization delay, not necessary, but I always suggest you give it in the one-time loop like this. So our LCD is now initialized with this pin configuration. Now the next thing is to write the code. I go to the forever loop, while one, forever loop starts here and then forever loop ends here. Now first of all, what I should write? I should write anything I want. So go to the right, again in the LCD library, there you have this command called LCD out. Double click on this and in this go down, and this is LCD out CP. This is the LCD out command here, there. In the example here you have this command, copy this, paste it here like this. Now this command, it shows that this is the syntax of the command, this is the row and this is the column. So start writing from the first row, first column, what it should write. Anything, I call it like display learning. So it will display learning starting from the first row and first column. Now again copy this command, paste it. Now start writing from the second row and first column, microcontrollers. I think microcontroller is a big word, so I have to write it in short form because we can only display, remember it's 2 cross 16, 16 characters in one row. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, that's fine, that's the short form. So this is the thing we are going to display on the LCD. So I build this code, there you have the build button, build it. Now I go to the, this is our PIC3 programmer tool that we are going to use. First select the microcontroller. PIC16F877A is the one I'm going to use, this one. Now click on read to make sure that your device is fine. Okay, reading device program. Okay, it worked. That's perfect. Now click on file, import hex file. This is the file we just created. Double click and click on write. Okay, wait for the new file to be written. Okay, wait. Okay, it is programming the device. Let's get to the hardware to see what is happening. So this is the hardware. Okay, let it write. Once the new file is written, you will be able to see the characters over on the screen, and you can adjust the contrast using the contrast adjustment resistor. So let's see what happens. Okay, here you go. I can see what I wanted to see here. Like I can see, I have to like lower down the contrast. So just use this knob to change the contrast. Okay, it is getting better. Okay, this contrast depends upon how much power your microcontroller and LCD is getting. Sometimes the current is too much, you have to lower down the contrast, else you have to higher up the contrast, but it depends upon what is the current you are getting for the LCD. So you have to adjust this accordingly. So if the power supply is same, then the contrast is no need to be adjusted. Okay, I think this is better. Okay, this seems way better. Because I am using the camera, and on the camera I cannot show you exact. So let me zoom out. Okay, this looks fine here. Okay, this is how it looks like. So you can see that we just got what we wanted to show here. So in the programming we wrote learning microcontroller, these digits, and we got them on the LCD. You may write anything you want to write. You may even send variables as well. So over here we are getting exactly the same what we just wrote. So guys, this is it. Same series. So goodbye until then.